Alright, last example is going to be on torque. And the idea of a cross product occurs often in physics. In particular, we consider a force F acting on a rigid body at a point given by a position vector r. For instance, if we tighten a bolt by applying a force to a wrench, we produce a turning effect. The torque, tau, relative to the origin is defined to be the cross product of the position of the force vectors. All right, so here we have tau is equal to the cross product of r by the vectors of r and f, and tau can also be expressed as the magnitude of tau can be expressed as the magnitude of r and f, which is equivalent or equal to just the magnitude of r times the magnitude of f times sine theta. Now, one thing that is what we'll probably have to do is find out this theta. All right, and now in order to find the angle between two vectors, so here r and f, more than likely what we're going to have to do is go back to finding that theta, which again was cosine theta is equal to the dot product of r and f divided by the magnitude of r times the magnitude of f. And then take the inverse cosine, and then we're able to find theta. Okay. And then again, in this formula, we're using sine of theta, so still that same angle. So a wrench, 30 centimeters long, lies along the positive y-axis and grips a bolt at the origin. A force is applied in the direction 0, 3, negative 4. At the end of the wrench, find the magnitude of the force needed to supply 100 newtons per meter of torque to the bolt. All right. So here we basically have our a wrench applying pressure to a bolt, and so here we can say here's our wrench, and our wrench is given in 30 centimeters, but what we want is meters. And so to go from centimeters to meters, it's just going to be 0.3. All right, so our wrench is 0.3 meters long. So what we're going to do is we need to find, okay, what is this R right here? All right, and then we also have our force acting upon it, and then we have our bolt, which is going to help produce our tau, our torque. And so we're going to have, for our wrench, it's 0 on the x-axis, it's 0.3 on the y-axis, and it's 0 on the z-axis. All right? And so that's going to be our vector from the initial position. All right? Again, the reason why y is 0.3 is because that's how long the wrench is. So starting at the origin, all right, our wrench is going to go 0.3 meters long, and then x and y, we're not moving at all. So there's our row vector. Now what we need is we need our force vector, and it says a force is applied in the direction, so we have our force vector, all right? So force is going to be 0, 3, negative 4. And what we want to do is we're given the actual magnitude, not the magnitude, but we're actually given, we're given the magnitude of tau. All right, we have 100 newtons per meter, but what we want to do is we want to find the magnitude of the force. And so again, we're going to our formula where we have the magnitude of tau is equal to, and the magnitude of r times the magnitude of f sine theta. And what we want to find, of course, is we want to find the magnitude of force. So this is what we want to find. And what we want to find, in order to solve this, we're going to need sine theta. So to go ahead and find everything, the first thing I'm going to do is I'm going to find theta, and so I'm going to have cosine theta is equal to the cross product of r and our force F. Not cross product, but dot product. 0, 3, -4. Divided by the magnitude of R times the magnitude of F. Alright, so we do our work, and the dot product, we're going to get 0 times 0 plus 0.3 times 3 plus 0 times -4. All that divided by the square root of 0 squared plus 0.3 squared plus 0 squared times the square root of 0 squared plus 3 squared plus -4 squared. So on top, we're just going to get 0.9 times 0.3 times 5. And so we're left with 0.9 over 0.15, which is just going to reduce to 3/5. Alright, now this all equals cosine theta. So that means that theta is equal to the inverse cosine of 3/5, which is going to give us approximately 53.1. Alright, so we found our theta. And so now what I'm doing is I'm going to plug everything in. So we have the magnitude of our tau, and that is 100. Let me change this color up a little bit so you know that I'm now coming back to here. So we have 100 newtons per meter. That's equal to the magnitude of R. So we're going to need to do the magnitude of 0.30, which we've already done on the right, times the magnitude of F. We don't know that. And then sine theta. I mean, we know that, but not with the added part of tau. Alright, and sine theta equal to sine theta, which is sine of 53.1. Alright, so now let's do some math. We're going to solve for the magnitude of our force, and we have 100 divided by 0.3 sine of 53.1. If you're asking where this 0.3 came from, it's our magnitude of R that we found over here. And that's equal to, that's equal to our magnitude of F. And that is going to give us around 417 newtons.